want to start looking at today is this. We want to start talking about some of the stuff where we're dealing with values that occur with our functions. Now in our graph right here, we've seen this before. This is just simply the graph y is equal to sine of x, right? And this is one whole cycle going from 0 degrees over here on the left to how many degrees over here on the right? 360, right? 360, right? So what I want to start doing is this. I want to go back to the notes that you guys have already, and I want to start looking at what do we do to these functions right here. If you notice right here, kind of right in here, we have a y is equal to, do you guys see the sine function in that box right there? Well, notice what I've done. I've put an a in front, there's a b out in front of the x, there's a c here, and then there's some value v at here. And what I want to tell you is this, these are values. We want to talk about what are putting these values in certain places do to the graphs right here, okay? In other words, if a was like a 5, and maybe b was a 7, and c was 2, maybe d was like a 6, you need to understand that all these values, a, b, c, and d, are just going to be some number, okay? And I want to talk about the effect that they have on these. Now, the two functions we're going to talk about first, sine and cosine, and we're going to look at what the effects of a, b, c, and d have on these, okay? This says right here, it says this equation will allow us to stretch and shift graphs of trig functions, all right? Let's just talk about what a, b, c, and d are right over here, first of all. What's it say a is? What does it say a affects? What's the word there? What's the word right here that says it affects? Anybody ever heard that word, amplitude? You've heard of amplitude? How many know what amplitude means? Okay, what's it say here in parentheses? Vertical stretch. If you notice up here in these functions right here, where is the a at? Well, it's out in front of the sine or the cosine function. So let's talk about what's going on here. Let's just say something like this. I go into the graphical calculator here, and I go in and put y2 equals here. Let's do this. Somebody give me an a value between 0 and 6. 3? All right. We'll go ahead and type this in. Y equals, what do we say, 3? 3 times the, let's go, how about we go sine of x right here. Okay? Guys, right here, looks to me like we put a value right in front of the sine function like they have right up in here, right? Okay? So what happens here is this. I put a value in for a in this graph right here. Describe to me what's going on here from y is equal to sine of x in red to y equals sine of, 3 sine of x in blue. What happened there? Basically, it's taking it, and its highest point is being stretched up, and its lowest point is being stretched down. So right here, guys, you know, from highest point to lowest point, didn't it get stretched out a little bit? Didn't it get stretched out? Okay. So this value of a, all it's going to do is take this value and stretch it out. Now, what if this was a value of a that was, say, maybe less than 1? Instead of stretching it out vertically, what might it do then?
Shrink it.
Collapse it. Okay. Any idea what a negative sign would do up here? What if this was negative 3 up here? Flip it. You bet. Let's just confirm that real quickly. Let's go ahead and put a negative right in here and see what happens. Still stretched, isn't it? Still stretched, but it's just flipped there, right? So guys, right here, when I go back to the notes in this right here, and I talk about what is the value of a affect, what's the word I'm talking about? Amplitude. Amplitude is going to be how much it stretches the original function vertically. Again, keep in mind, we're only talking cosine and what right now? Cosine and sine. Okay. Now, we'll talk about this above and below the value of b here in a second, but next thing we need to look at is this part B. Okay? Part B says it determines the what? What's the word? Period. Okay. Remember in the last section how we talked about graphs repeating themselves every 360 degrees or every 180 degrees? You guys remember that? Okay. If I go back to this graph right here, and I look, I'll get rid of this one. This is one period of this is one period right here of sine of x, because it goes from 0 degrees, goes all the way up to 1, comes back down to 0, travels all the way down to -1 down here, and then back up to 0. Now this red graph for the sine of x, if I would go beyond 360 degrees, what's going to start happening with this graph? What's it going to do? Isn't this just going to start repeating itself over and over and over again? So this pattern gets repeated every how many degrees? 360 degrees. If I go in here and change this window, if I change this window right here, instead of being 360, let's say it's maybe, I don't know, 720. You guys see the first cycle right up here, all the way up to 1, down to -1, back to 0. At this point right here, isn't that kind of like the halfway point for another? Isn't that like a second cycle starting over again? Isn't that like a second cycle starting over again? It is, isn't it? Okay. So when we talk about cycles, the question is, every how many degrees does a function start to repeat itself? Well, in this case, every 360 degrees. Now, if I would go in here, go back to my window of 360, I want to know what effect B has on something. So I'm going to change this again to 360. Okay. What would happen if I put a value right in here? Say maybe, I don't know, 2. Guys, what did that 2 do to the graph? Did it change the amplitude? Did it stretch it vertically, in other words? Did it stretch it vertically at all? No, the highest value and lowest value are still 1 and -1. But what about the amount of time it takes for a cycle right here? Notice, an original cycle for this was 360 degrees. Now what's an original cycle? Going from here to here. It's now how many degrees? Every 180. Okay, every 180. So this effect of B right here, what we're going to talk about by the x, is B is always the value right next to x. Let's see, there it is. This value B right here is going to say what we is determining the period. And there's a formula up here for it. It says it's equal to the old period divided by what? Old period divided by what variable? B, right? Okay. Old period divided by B. Guys, what was in that sine function that we started with? How many degrees does a sine function take to repeat itself again? What was the original amount that we found in the last section? Every how many degrees? Every 360. Well, what was the B value I just used in this function right here? The B value I used there was 2, right? Okay, so what's 360 divided by 2? For 180. So let's say if I start at 0 here, go all the way up to here, down to here, back around, at 180 degrees I've completed one cycle. So that B value is going to determine your new cycle time. Okay? What if this was a 4 up here instead of a 2? What would 360 divided by 4 be? 90. So the bigger those numbers get, basically, if you can think of it as like a spring. If I take a spring and compress it, can you see what's happening there? The pattern repeats itself sooner. But if I take a spring and stretch it out, you see what's going on there? So the higher the value, the more compressed it's going to be. So what I like to put down here in your notes, and maybe you want to do the same, is this. This part right here where it says determines a period, it's going to equal your old period. Typically up here, you might want to write down it. It's typically about, for sine and cosine, the number that you would have in there for an old period would be like either 360 or 180, depending on the function. Okay? Typically it's 360 or 180. Okay, 360 and I'll put it this way. You might want to write it down this way. Let's go 360 for sine or cosine, or 180 for your tangent functions. Okay. So you might want to write that down there. Whoops, I didn't want that to happen. There we go. This is typically every 360 for sine or cosine, and 180 for your tangent function. So you might want to write that in there. That old period value is typically that, okay? All right, let's say your C value does right here, guys. It's a phase shift. Basically, it's instead of being a vertical shift, it is a horizontal shift. It's either moving the graph left or right. So as an example right here, if I go back into this function right up here, let's just say I've got the sine of x again, okay? Let's say I put in maybe plus 90 like this, okay? And I'm going to put the original function, y is equal to the sine of x in here. All right? If I go plus 90 right here, you guys see how this point may be right here at, well, 180 degrees right here? This point at 180 degrees is now shifted over to, see where I'm pointing right here? See where I'm at here? The red is going to be like the original, I'm sorry, the red is going to be the sine of x plus 90. The green is like your original function. This point appears to be shifted over how many degrees, guys? 90 degrees, okay? So basically, anytime you're adding a C value in here like this, what kind of effect does that have on the graph? Shifts it left or right. I'll talk about this more specifically here in a second. But the last variable you have there is a letter D, is that right? Is that right? Somebody give me some sign that you're alive right now. Yep. Okay, here's your sine of x, right? If I add, say, maybe plus 2 on the end of it, tell me what happens here. What happened to my graph? If this was y equals sine of x, purple one's the original graph. What does this addition of 2 out here on the end outside of parentheses do? What's the effect? It just takes it and shifts it up 2 units, right? Shifts it up 2 units, right? Okay? Good there? All right. So, guys, just making sure we understand what all these terms mean. We're going to look at an example here in a second, but what's the A value effect? The amplitude. Now, A is typically out in front of a sine or cosine function. The B value is the value right in front of the x here in parentheses. That determines your cycle time, or your period, if you will. The C is going to determine the phase shift, how far left or how far right we're going. Something that's going to be really important for you guys to write down or know is this right here. Know that right there. Very important. Put a star by it, okay? Might want to put a star by that one right here. This is pretty important. What's it say your phase shift is equal to? It is horizontal shift. Well, what's its formula? Opposite of C divided by B. Okay, good. Vertical shift, just how far up or down you slide the graph. And we'll talk about that. That's the D value. So I've got an example down here. It says determine the amplitude period and the PS of what? Well, what's our function right here, kiddos? Y is equal to 10 times the sine of 3x. Okay, I'm going to go back here real quickly. First of all, the amplitude. And I like to write this down here quickly. Write this down. Oh, there it is. Right up here, I'm going to write down y equals, whoops, what is that doing here? All right, y equals a sine of bx plus c plus d out here. Whoops, come on. Okay. Which variable determines amplitude according to this up here in your notes? A. Okay, what is the A value in this function? It is 10. Okay, so your amplitude is going to be 10. Right? Then the period. Let's see, what kind of a function am I dealing with, guys? Sine function. Up here I said the old period for any sine function is always, how many degrees right here? 360. So I'm going to take 360 and divide that by a B value. So this is really going to be 362 degrees divided by, what is the B value in this function, kids? 3. right? So 360 divided by 3, which is what? 120. A phase shift. What's it say your phase shift is? Which variable affects phase shift? Basically, it says C and what? B. That says the phase shift left or right is the opposite of C divided by what here? B. Well, guys, is there a C value in parentheses with the 3x? What is that C value really then equal to? 0. So this would really be 0 divided by what? 0 divided by 3, right? Which is still what value? 0, is it? So how much phase shift is going on here? How far left or right am I shifting this? You are. Okay? Still be 0. Okay? So let's just check this out. Let's just check this out. I'll go back into this function right here. Okay? And I'm going to change my window here quickly. What was the function that we were putting in there? The one that we just answered. Okay. Okay, here's the original y is equal sine of x, right? Amplitude's 1, cycles 360 or periods 360. The function we wanted was y equals, was it 10? Is that right? 10 sine of what? 10 sine of what? Was it 3x? 3x?
Yeah.
Okay. Let me change my window here. Change the y-axis here a little bit so we can see negative 11 up to maybe 11 here. All right. Guys, check. Whoops, didn't want that. Here's what we want to see. Okay. Guys, the original function, the highest point was always at 1 right here. What's the highest point in your new function now, guys? 10. It's up here 10 units. Okay. It's 10 units above and 10 units below. Isn't there like a line of symmetry right here in the middle? Kind of cuts this in half. That amplitude just means how far above and below the middle of that, the word is sinusoidal, or this repeating graph, how far above and below do you kind of get above or below the middle? Okay, so that 10 right here. Guys, this here was stretched out for a whole cycle this far. Does this look like it got compressed or stretched out then for the purple graph? Compressed, okay. We took 360 and divided that by what? Divided it by 3. We said, you know what? A phase shift would go from 360 divided by 3, which we said was every how many degrees? Well, every 120, right? Take a look at this graph right here. Doesn't this graph go up to here, all the way up? Starts here, all the way up, all the way down. Do you guys agree that right here, this is where the pattern starts repeating itself again? Right here, started here. How many degrees am I at right here, guys? 120. Okay, and then phase shift. Did this point right here move left or right at all? Did the point where we started both, did it move left or right for starting points? Did it? Okay. So what's the A value effect again out here? 10. That's just the amplitude. All right. Here, this is going to determine your new cycle. We'll look at a phase shift here and a vertical shift, but I think these are pretty self-explanatory, honestly. Right? All right. Let's look at the next one here. Guys, the next one's going to start talking about the tangent function. Okay, the tangent function. When I do these problems, I like to list my A, B, C, and D values right here. So I'm going to do that right now. In this right here, gang, off of this function, we're dealing with the tangent. What's the A value, by the way? What is your A value? Negative half. All right, so write that down. How about your B value? What's the B value? What's the B value? 0.25. How about the C value in this? What's the C value equal? 10. Okay. And then how about the D value? Is there anything out here beyond this parenthesis? So what's the D value really equal here? 0. Okay, well, we'll write this down. So I think it'd be your benefit to write this down here. All right, right here, guys, it says in a tangent function there is what for amplitude? Well, there is no amplitude. Now remember, amplitude takes the highest and lowest points and does what to them? Stretches them out. Okay, but if I go into my graphing calculator right here, guys, talk to me about why tangent won't have any amplitude. Let's punch that in here quickly. Let's just go, I want to type. Let's go y equals, and then the function I want was the tangent of x. Okay. Here's the graph of this right here. Now, do you guys remember that there were asymptotes every 90 degrees for this right here? Okay, guys, why is there no amplitude for a tangent function? Well, if I could draw right here, and I know it's not going to show up on the screen, but if I could draw an asymptote right here at 90 degrees like this, is this orange line ever going to cross this asymptote that I just drew up here on the board? Never will. And what's going to continue to still happen to these points? Is it ever going to hit a high point, or is it going to continue to go on forever? Okay, so like in a sine function, you had an absolute highest point and an absolute lowest point, didn't you? But in a tangent function, are you ever going to have an absolute highest point or an absolute lowest point? Braxton, what's up, bud? Where are you going? Oh, okay, I forgot. Listen, you turn 40, you get CRS really bad.
What's CRS?
I don't know, I can't even remember what that stands for either. Okay. All right, see ya.
See ya.
All right, so tangent's never really going to have, I'll put this one, anything, you remember those functions in 6.1 that had asymptotes in it? Anything with an asymptote in it will not have amplitude to it. Even though there's a value, you can say, yeah, it does have an amplitude. It really won't. So anything with an asymptote will not have amplitude. Does that make sense? Okay, because it just continues to get higher and higher and higher and lower and lower and lower. Okay? So, heading back here then, the question said, does the tangent function have amplitude? And we said none. And what was, I think it said y, didn't it? Didn't it say y? Well, I guess the best reason to put there is because it has a vertical, what's the word? Vertical asymptote, right? It's a vertical asymptote, meaning that the range goes to from negative infinity to positive infinity. There's no end to it. Okay, so what kinds of functions will not have an amplitude? Well, do you guys have your 6.1 notes handy with these graphs right here? See them right here? Remember this paper right here? Well, the only one that didn't have asymptotes in it was sine and cosine, right? Everything else had some kind of an asymptote, whether it was tangent, cotangent, cosecant, or secant. Of all these 6 functions up here, which ones can have amplitude? Sine and cosine are the only ones that can have amplitude. All the others won't have it because they have vertical asymptote. Okay? That makes sense? Okay, so even though there's an a value there, the only time you're going to apply that a value is when you have sine or cosine. Okay, how about your period on this? What's going to happen to the cycle time, if you will? Guys, in a tangent function, what was the repeat time in section 6.1? You guys remember that? Every 180. So we're going to take our old period time of 180. We divide that by the b value. What is the b value here, kiddos? Divide that by 0.25, and that'll tell you how often that function repeats itself. Well, what is 180 divided by 0.25? You get 720 when you do that? Is that what you end up with? Okay. So the new period, or how often this graph is going to repeat itself, is going to be every 720 degrees. Okay? And I'll graph this here in a second just to confirm all of this. Last thing, talked about phase shift. Okay? Kind of want to talk about this phase shift right here. This is pretty important. I should get rid of that line up there. It's kind of annoying, isn't it? There, is that better? Talk about this phase shift. All right, help me out, gang. This phase shift. What did it say the phase shift was equal to? Up top here. Opposite of C divided by what? B. Okay. I want to make a note here. Can I make a note here? Is that okay? Is that okay? Well, you know what? I don't think I need to do that. You know what? I don't need to do that. Just forget it. Don't worry about this. This will all be good. Phase shift, opposite of C divided by B. What's your C value up here, gang? 10. So this becomes negative what first? Negative 10 over your B value of 0.25, right? What is that? Negative 40? Okay. Guys, when you get a negative 40 like this right here, this negative 40, a phase shift is indicating how far left or how far right. When you get a negative 40, what direction are you shifting your graph then? 40 degrees to the left, okay? So here's what I want to do. I want to kind of go ahead and just talk about what all these numbers mean in terms of that graph up here. So here's what we're going to look at. Can somebody at least remember to tell me the function of this right here to plug in when we get to the decimals? Bad circle, but this one right here. I'm referring to this. You help me type that in here in a second. Okay, here's what I've got. We've got the original function y is equal to tangent of x. I'm going to change this here because what did we say that our new cycle time was going to be? Every 720, is that right? Okay, I'm going to go ahead and change this up to I'm going to go about negative 90 degrees to about every 1080. 1080, that'll work. Okay, I don't want that much. That's what I want. Okay. All right, that's the original tangent function right there. Original tangent function repeats itself every how many degrees? Well, every 180. This point right here, matches that point at 180 degrees. Agree with that? This is the original one. Now, what's the new one we were looking at? Let's just type this in. Okay, what was the new function? Y equals, who's got it? Negative 0.5? Negative 0.5 times tangent. Is it x plus 10?
No, 0.25.
0.25x plus 10. Okay. Now I'm going to change my window again here a little bit so we can see multiple values. So I'm going to add another 360 to this. So that would make this 1440. All right. Let's just kind of look at what's going on here. First of all, what effect did the negative out front have here on this? It flips. Okay, so that negative is going to flip it. Okay. What did we say our new cycle time became, or our new period time? Every 720 degrees, right? Okay. Check this out. This function right here. This function right here, that's a good one. So this point right here. You guys see your new points right here on that function? Do you agree that the point here and here match each other for that tangent function? Like this? You guys agree with that? We went from negative 4.5 degrees up to how many degrees here? 715.5. What's 4.5 plus 715.5 match up to be? What's that add up, I guess? 720. Isn't this graph repeating itself every 720 degrees again here? Would you guys agree with that? Okay, this point may be right there. Oh, negative 40 comma 0. You remember that shift left at 40 degrees? Remember that shift left at 40 degrees? Guys, what's the tangent of 0 equal to right here originally? Well, 0 started at 0 on the orange graph, right? Now all of a sudden you get this black graph to start at 0 right here. How far left is it? Negative 40. That negative 40 is basically saying instead of starting at 0 comma 0, you're starting at negative 40 comma 0, or 40 degrees to the left. And didn't that 40 degrees to the left match that value right here? Okay, so let's just talk about this again real quickly. Amplitude, going to move your highest and lowest points, but amplitude is only effective on which two functions? Sine and cosine. Okay? Do you understand what happens here with the period? You're either stretching it out or you are compressing the amount of time it takes to complete one cycle. You okay with that? Here's the deal. In this example right up here, was B more than 1 or less than 1? It was more than 1, right? Think of it as like a scale. If you have something that's heavy or big or something like that, and if you were standing on a spring, would the spring compress or would it stretch out? Yeah. Compress. Like, so I took my weight times a positive 3. Wouldn't the spring compress? Do you agree with that? Okay, so anytime this B value is more than 1, what happens to the cycle? Does it increase from the old period or does it decrease? Well, it's going to decrease or compress, right? If I took maybe my weight, if I said took a quarter, if I was standing on a spring, I said take my weight times a quarter, in other words, reduce it, is the spring going to compress or expand? What would it do? Natalie's standing on a spring. Natalie's right here. Natalie's standing right here on a spring. If I cut Natalie's weight in half, is the spring going to move up or is it going to compress further? It's going to move up. Okay? Makes sense? So anytime you have a value less than 1, what happens to your cycle time? From the original to the new one. Does it get bigger or get smaller? Bigger. Right? Alright, so let's talk on this last one. I don't even want to talk about what this looks like graphically. You help me out here. First of all, secant. What's the amplitude? You don't have one, do you? Okay. What number would you look at if you were talking amplitude here? 10. Okay, but it's not going to have anything because it has some kind of a... Okay, so there is none. There is no amplitude. Okay, you guys tell me what the new cycle time is then for secant. Or period. I use cycle all the time. I don't know why. Period is what they use in the book. I call it a cycle a lot. So if you hear me say cycle, it just means the period. Okay? It would be 360 divided by 3. You bet. What do you get there, Kaylee? How much? 120 degrees. Awesome. This is easy. Just a bunch of formulas, isn't it? How much phase shift? Rough roll, Peggy. What's your phase shift? What's the formula for phase shift?
It's the
Opposite of?
10
Negative 10 divided by 3, you bet. Okay. Done. 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 What do you guys think? So far, so good? Okay with this? Take a look at a couple of examples. If you can understand what A, B, C, and D mean here, we haven't talked about D very much. We'll get you an example there in a second. But I think if you can understand how we come up with these numbers and what they mean, that's going to help you with what we're really trying to accomplish on the next page. Questions about the first page at all so far? Do you guys have an example at the bottom of the first page that looks like the example at the top of my first page right here? Is that what it says? I think you have just this first part at the bottom of that page, don't you? It says, write the equation of the sine function with an amplitude of what here, guys? Amplitude is 3.14, a period of 180 degrees and a shift of 30 degrees. Okay. This gives you all the values right here already. Okay, I want to know how they come up with this. I want to know how they come up with this. First of all, what kind of a function am I dealing with? What's it say? Dealing with the sine function. Okay, you have an amplitude right here, and they give you the answer right down here. That amplitude for the sine function, first of all, that works because we can put that in. That's got to be the a value in this, okay? Remember, we're talking about y equal a sine of bx plus c plus some d value. And they don't talk about a vertical shift in this one at all. But the a, b, c, and d would take those spots right there. Question? You okay with that?
Yeah.
Okay. All right, first of all, do you understand why a is 3.14 in this? Why is a 3.14? It's the amplitude, okay? You just throw that in for amplitude, okay? You just throw that in. Okay, so that's got to take the place of a. Now, I'm confused about the b value. The b value determines what for us? What's it say b determines for us? It says it determines a period. Well, up here it says you have a period of what? 180 degrees. That's the new period for this function, but I don't see anything that involves a 2 up there. So how in the world are they getting that? Okay, 360 divided by 2. Okay. On that first page, guys, I'm going to abbreviate stuff right here. I'm going to abbreviate some stuff. Is that my imagination, or did I hear something?
Hear what?
Was there like a bell that just went? Okay. All right then.
You're crazy.
I am. Okay. Guys, on the front page of your notes, it said something to the effect about periods. New periods, I'm going to abbreviate this. The new period, I'll abbreviate new period can be found by taking the old period divided by the what? Divided by the b value, right? Okay, in this problem right here, what did they give us as the new period? How many degrees? 180, right? So from this right here, we can say, you know what? From this, 180, the new period I want, had to evolve from. Okay, think about this. We're dealing with what kind of a function here? Sine. And we had said originally in the last section that the sine function repeats itself every how many degrees? 360. So the old period would have been 360, right? Guys, this is basically saying 360 degrees divided by what b value would determine that new period of 180 degrees? Well, 360 divided by what? 2. So that's how they come up with that. Does that make sense to you? Okay. Good with that? All right. How about that c value then of negative 60? What's the c value kind of have an effect on? What's it say on the front of the page? The c has an effect on the phase shift. Okay. Well, do you have a formula for the phase shift? Isn't that the opposite of c divided by b? Isn't that the opposite of c divided by b? Okay, watch this, kiddos. In this problem right up here, what do they say the shift is? What value? 30 degrees. They want the phase shift to be positive 30 degrees, right? 30's got to equal opposite of c divided by the b value. But don't we know the b value now? Don't we know the b value? It's 2, isn't it? So what can I plug in for the b? Well, I could plug a 2 in here. Now to solve this right here, to get c all by itself, or find that c value, couldn't you multiply both sides by 2 first here? So this means that negative c from this would be, or in other words, negative 1c would equal 60, wouldn't it? If I took 30 times 2 right here, this would be negative c alone, would be 60, right? What are you going to take 60 and divide it by now to find that c value? Well, what do I have in front of here since it was a negative c? It's a negative 1, isn't it? What are you going to divide by? Negative 1, good. So what's that make the c value here, guys? Negative 60. And once you have those values, by the way, was there any vertical shift up or down in this problem? So the d value will stay at a 0. I'm just going to jot this down. D will stay at 0. Okay. We're going to add some stuff here to this next one. But guys, what do you think? What do you think? Can you use those formulas to find your values? Final function becomes y equals 3.14 there because of the amplitude. Sine of 2x, the 2 determines your new period for 180, and this negative 60 divided by, or I should say the opposite of negative 60 divided by 2 gets you your shift of what? 30 degrees here. Okay. All right. So let's see if we can't figure one of these out. I'm going to add one thing up here. I'm going to put a vertical shift right up here. Vertical shift of 2 for this next example. Okay. Let's get this last example done, and we'll call it good today. Okay. Remember how I said anything with an asymptote won't have an amplitude, right? Right? However, all of a sudden this next example says write an equation for what? tangent where the amplitude is what value? Where the amplitude is what? 0.45. Somebody might say, well, wait a minute, you just said tangent can't have an amplitude. Technically it doesn't, but we use that 0.45 to be able to still form the graph. So when we're writing equations like this, they have to give you that amplitude value in order to be able to write an equation. So here we go. A is the amplitude. Okay? First of all, understand what it is, tangent function. Okay? When I do this right here, I'm going to put the number 180 up here. Now why would I put the number 180 up here for a tangent function? It repeats itself every 180 degrees, right? The old period is 180. So help me out here. What are you going to put in for an amplitude value given the information up here? 0.45. I agree. Good. Okay. I'm kind of done talking. You guys tell me how to find the B value for this. Okay, first of all, it says we have a new period of how many degrees here, guys? Okay, we got a new period of 1080. So the new period, 1080, has to equal the old period, which was what, guys? 180 divided by which variable? B. Now, guys, I can make this really difficult or I can make this really easy. What do you choose? Make it really easy. Isn't 1080 the same as 1080 over 1 right there? It is, isn't it? Isn't that just a proportion to solve for B now? So 180 times 1 divided by 1080. Do you get 0.16 repeating? You do? Okay, so your B is 0.16 repeating. Anybody know what 0.16 repeating is as a fraction? Close. Turns out to be 1/6 actually. So your B value here would be 0.16 repeating. Okay. All right. Or I could say this. If I said this right here by proportions, I could say 1080B has to equal 180, right? You okay with that? And then you would divide by 1080. Or you would have 180 over this, which would reduce to 1/6 if you want. Okay? So I don't care if you put it as a decimal, I don't care if you put it as a fraction, totally up to you. Okay, what's the phase shift up here, guys? What's the phase shift up here? -20, okay? So this phase shift right here, to determine C, the phase shift of -20 degrees has to equal the opposite of C divided by my B value. And what did we say B was here, guys? 0.16 repeating. Right? So do you agree that I could take -20 times 0.16 repeating here? Okay, do that for me. You get 3.6 repeating here. I'm sorry, -3.6 repeating. You would take -20 times 0.16 repeating, wouldn't you? Punch it up here quickly.
-0.3 or -3.3.
3.3 repeating?
Negative.
Okay, so this means negative C equals -3.3 repeating. Okay, so what would I have to divide everything by here to get C alone now? Well, really, this is -1C, isn't it? Okay, so -3.3 repeating divided by -1 would be what value? Okay, and then finally it says a vertical shift of 2, meaning up 2. So what's the D value really equal here? Like, well, let me fill the C value in. 3.3 repeating. And then finally the D value, just shifted it up 2 units, so what's that going to be? Just 2. Okay, so let's fill in what we know. Again, we want the A value here for amplitude. B determines the period. the C and the B are going to help the phase shift, and the D is going to help with the vertical shift. So what's going in for A down here? What's going in for A? I think an elective course, don't even listen. Blows my mind.
Hey, did you just put the vertical shift in there?
Yeah, I added that because we haven't looked at an example that way. So yeah, I added that to the original part of the problem. Yep. Okay.
0.45
.45. Go ahead, Cole.
tangent, and then in parentheses, isn't it 16x
Okay.
plus 2? Or is it?
3.3.
Plus 3.3.
Oh, yeah, sorry, I was.
Nope, you're good.
3.3.
And 3.3 repeating is really 3 1/3, isn't it? Okay, I want to show you something real quickly when I get done with this. And then finally, the D value of what?
Plus 2.
+2. Now, I want to show you something real quickly. If you're looking at stuff up in the back of the book, they're going to do a couple of things. If I take 1/6 of something, that's like taking your original value and dividing it by 6, isn't it? Okay. So what I might say is something like this. I might say, you know what, this is really 0.45 tangent of x over what? X divided by 6. 1/6 of something is just the same as dividing by 6. They're going to write it that way. So if they have that fraction out front, you might see it that way. 3 1/3, guess what they're going to call this? Isn't that what we kind of had right? Oh, where did it go? Am I lost or what? Where is it? Okay, we had 3 1/3 up here, but we did take 10 and divide by 3 at some point. And then plus what out here? Okay. Just understand that what we might have in this form or with decimals in here still matches what they might have in simplified form when you're looking stuff up. Okay? All right. First of all, my first question is, do you understand the A, B, C, and D part of this? You okay with that? There's some tricky stuff going on here. I think if you can apply the formulas and say, okay, I understand what A, B, C, and D do. If you can come back and look at this sheet right here as you're working through your assignment, I think this will make a lot better sense. Okay? 315. I said, what, 5 to 43 odd, is that right? Okay, let's shoot for Wednesday on that. Okay, let's shoot for Wednesday on that. And idea being that we'll have some time to work on this a little bit tomorrow and ask some questions tomorrow. But a lot of tricky stuff here, but I think, again, if you got the notes down and you've got the formula stuff, I think you'll be in really good shape, okay? No, I hadn't turned any attention. All right, you guys have a great day.